Okay, chapter 3, section 5. Almost done with chapter 3. This is the last section, and compared to all the stuff we've done, this is a very, very simple section, so hopefully this won't cause any problems. And really, we've already kind of done some of what we're going to do. We're going to learn about box plots. So we're going to compute the 5-number summary, and then we're going to use that to create and then interpret a box plot. Okay, so what is the 5-number summary? So the 5-number summary of a data set, of a set of data consists of, and then these are it, the minimum value, the smallest value in our set, Q1, the first quartile, the median, the third quartile, and the largest data point, right? So those are the 5 characteristics of the data that we're looking for in order to create the 5-number summary. For example, every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the United States. The following data are the interest rates charged by 10 credit card issuers randomly selected for the July 2005 survey. Determine the 5-number summary of the data. Okay, so let's look at our results. Okay, so here's one bank, and the rate is 6.5%. Here's another bank, and their rate is 12%, and so on and so forth, so on and so forth. Notice that they are not in ascending or descending order. They're just kind of randomly provided for us. So these are all the different percentage values. And we want the 5-number summary. Okay, well, finding the minimum value is super easy. We just kind of look through it and easily find that, this has to be the minimum value. Yep. And then finding the largest value is also very easy. So let's call that the min. And finding the largest value is also easy. That's 14.5 is going to be the largest value. Just so happens it was the first and the last value. Right? So it's not in order because these are out of order, and that one's, it's not in order. Okay, so we got the min value, we got the max value. We also need the first quartile, the second quartile, and the third quartile. And we've covered before how to do that by hand. And with a very small number like this, is very manageable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, and equals to 10. Okay, so we've already covered in previous sections how to find the median by hand, right, when there are an even number of entries. Once we find that median, we can find the first quartile, we can find the third quartile. Let's instead use our technology to find all those results. Let's go over to our calculator. Okay, so hit clear. I'm going to go to stat, enter. I'm going to use, let's use list 2. Clear, enter. So I'm going to work with list 2. Just keep in mind which list you're using. And now I got to input all of these values into list 2. So I'm going to leave them as a percent, just knowing in my head that that's what it is. So 6.5%, so 6.5. There they are. Okay, so now we're going to go to stat, calculate one variable statistics on L2. So on L2, down, calculate, and there is anything and everything I'm going to need for this. It identifies the min value, okay, 6.5, just as we thought. It identifies the max value, which was the 14.5, and we get Q1, Q2, which is the median, and Q3. So we get everything we need right there. Just going to write those values down. So I have Q1 equals to 12. I have the median equals 13.6. And Q3 equals 14.4. Good. Okay. I also need the min and the max. Well, I'll write them down over here. The min was equal to 6.5, and the max is equal to 14.5. So those are the 5 points we need. 5-point summary. Okay, so now let's use that to create our box plot. The next thing we're going to need is to find the IQR value. IQR is equal to Q sub 3 minus Q sub 1. Well, that's going to be equal to 14.4 minus 12. So 2.4 is my IQR value. Okay, now that I found my IQR, next I'm going to need to figure out what the upper and lower fence are. So let's figure out my lower fence. Lower fence is going to be equal to Q1 minus, remember it's always 1.5, times the IQR. So for us, that's going to be equal to 12 minus 1.5 times 2.4. Good, that's my lower fence. And so using my calculator, that's going to be 1.5 times 2.4, and it's 12 minus that. I'm getting 8.4. My upper fence is equal to Q3 plus 1.5 times the IQR. Good. So the Q3 is going to be 14.4 plus 1.5 times 2.4. So that'll be 2.4 times 1.5 plus 14.4 is 18. Okay, so that's all I need to create my box plot. Once you find all those things, then you're going to follow these sets of instructions. I got my 5-number summary, which is this one. Let's make sure it matches. The second, okay, so the first quartile was 12. The second quartile is 13.6. And the third quartile is 14.4. Okay, so my 5-number summary is this. That matches with the scores we have right here. So this is my 5-number summary. 1, 2, 3, 4, 5-number summary. And that matches with this guy. Next, we're going to create a box plot, and we're going to follow these instructions. First, we need that lower fence, which we already found. The upper fence, we already did that. We're going to draw a line long enough to include the maximum and the minimum. That'll be our horizontal axes. Then insert vertical lines at Q1, M, and Q3 to enclose these lines into a box. Okay, so we're going to do the following. We're going to summarize those values in the following way. Create a number line. It's supposed to be straight. And then we're going to think about where is Q... let's go in multiples of 2. Thank you. Okay, so now our 5-number summary. So we had that the first quartile was at 12. So Q1 is at 12. This is Q1. Q1 is at 12. And then Q3 is at 14.5, so right around here is Q3. And we're going to create a box that includes those. And then inside that box, we're going to put where the Q2 is, the median, which in our case is at 13.6, so that would be kind of like right around here. I'm going to put it in a different color just to highlight it, but it doesn't have to be in a different color, so something around there. And so that one would be Q2, the median. Good. Okay, next we're going to establish where our lower fence and upper fence values are. So we already calculated those. They were up here. 8.4 and 18 were our lower and upper fences. 8.4 and 18. So 8.4, we're going to put a little fence over here at 8.4, which is a little bit past this, so say like around there. And then at 18 is the other one, somewhere around there. Okay, and next we're going to look at our raw data, and we're going to find the smallest number in our original data that is to the right of the lower fence and identify it. So let's look at our original data. Here is our original data, and the smallest number that's to the right of that lower fence, it's not the 6.5 because that's over here to the left of that. In fact, I'll just go ahead and put it over here. 6.5 is maybe somewhere over there. 6.5. But 9.9 is the smallest number to the right of that lower fence. So I'm going to identify it there. And what I'm going to do is I'm going to draw a line that goes from Q1 out to this number, the smallest number to the right of the lower fence. And I'm going to do the same thing for the upper fence. And the largest number that's to the left of the upper fence, well, that is the max value of 14.5. It doesn't go very far, so that's going to be kind of somewhere around there. And that's going to lead you to 14.5. Okay, so this is what we call our box plot. Box plot. All right, let's see how the author drew the same thing. Let's look at the instructions. Okay, so we draw a box that extends from Q1 to Q3, and then a line right in the middle where right where the median should be, which is not always going to be right in the middle of the box, we should note. Okay, then we're going to label and draw our upper and lower fence. Draw a line starting at Q1 to the smallest data value that is larger than the lower fence. And then draw a line from Q3 to the largest data point that is smaller than the upper fence. Right? Any other data points that are lower than the lower fence or greater than the upper fence are outliers and should be identified with a little star. Okay then, so then this is what it would look like. All right, so this would be the final presentation. Let me just zoom into it. All right, so this would be our final box plot right in here. And I'm just going to write some stuff on it just to highlight some of our key values here. So note that the box includes the Q1 value. So that means that this is Q1 approximately, right there. And then that this is Q3 right in there. So this one is Q sub 3, right? And then right in there, that one refers to Q1. And then this is the median. So right around there. This is the Q sub 2 value. Okay. Then this guy is our lower fence over here. And now over here, this guy's representing our upper fence. Okay, so this little star is a value in our original set that was lower than the lower fence. It's outside that lower fence on the lower side. Therefore, this is one of our outliers. Okay, and so when we see this, we should note that, we should realize that um, this whole thing from here to here represents the middle 50% of our data. And the space from here to here, all of this represents 25% of our data. And so does this. From there to there. Also, the tiny little space right here, this little nub here, this little whisker, right? We call these lines whiskers, also represents 25% of our data. Right? It goes from Q3, and in this case, it goes up to our maximum value. And then from here all the way out to there, including the outlier, represents the lowest 25% of our data. But if we ignore the outlier, then we could say that roughly, it's not quite exactly because we're ignoring one value in our set, but roughly about 25% of our data is in this lower whisker as well. Right? So we break up our data into 4 sort of regions, and what we notice is that there's a lot of space here, a little less, but still quite a bit of space there, and then it gets a little smaller there, and then a tiny, tiny little nub there. That lets me know that a lot of my numbers in my data set are clumped up right around there in this little region, whereas over here there's a little bit more spacing, right? They're more spread out over here. Okay, so a box plot tells you about the distribution of data. How is it spread out? Where is the middle of the data? The middle 50% of the data. And then furthermore, how are they broken down into little in little sections? The lowest 25% of the data, the highest 25% of the data, so we can get a sense of how information is clumped up. This helps to make sure that we don't fall under false impressions of the data when there are outliers. For example, had there been one outlier way out here, let's say that there was an outlier out there, we would have extended this whisker all the way out to the maximum value. We would have gotten a false impression that this is really, really far out to the left. Same with the lower bound. If we didn't do this lower fence outlier thing, we just extended this whisker all the way down to the smallest value, we would have gotten a really long line on the left whisker. We would have been under the impression that this whole space here takes up the lowest 25% of the data, but it's really that one outlier is really dragging it over there. And then it would have been even more dramatic on the right-hand side. If there was an outlier to the right, way out there, we would have extended this right whisker all the way out to there, and then we would have missed the fact that the data is actually really clumped up really close to there. We would have thought, oh, look, it's all spread out from there all the way out to that value, right? So doing this process of finding the lower and upper fence and then separating the outliers gives us a better idea of how the data is spread out. All right, let's take a look at some other, so let me erase this guy here because that's not part of the original. So let's take a look at other distributions and their box plots so we can see how we can interpret them. So for example, let's look at some other distributions and how they compare with their box plots. Let's take a nice symmetric distribution like this one, right? Kind of bell shape, goes up, comes back down. If we look at this one, the box plot will look like this. Notice that about half our data is inside this box and that the median is right in the middle. And then that the left whisker and the right whisker kind of extend the same length, right? So this kind of box plot is describing something that's bell-shaped like this. On the other hand, this kind of box plot, notice that the left whisker is really tiny, really small. 25% of my data is found in this tiny little whisker, which indicates that a lot of data is clumped up in this little zone. Same as this graph, right? This indicates that a lot of scores are right on this bar, right? It goes up really high. Good. And that the fact that this is really long, this is 25% of my data is found in this area, means that it's a little bit more spread out, right? So this is indicating that the data is skewed right, clumped up to the left, it's skewed right. And this one is the opposite. Notice how this little whisker is really small. Independent of how long they are, the little whiskers always represent 25% of our data. This is the top 25%, the bottom 25%, and then the box represents the middle 25% of our data points. So if the middle box is really, really small, it means everything's clumped up in the middle. If the middle box is really big, that means that 50% of our data, so it's really spread out in that between Q1 and Q3. Okay, so this is indicating that a lot of our data points are kind of clumped up in this top end, right, which is helped out by this, right? It's interpreting this. There's a big clump to the right. And then the middle 50% of the data is found between these two values, between Q1 and Q3. The median is found right here. So again, that there's a further clumping between the 50th percentile and the 75th percentile. There's a lot of values trapped right in there. And then there's the lower whisker, which traps the lowest 25% of the data, approximately. And this indicates that there's no outliers because there's no little stars anywhere. Okay, so the last thing we want to think about is how to use our technology, our TI calculators, to create one of these box plots. That is something we will be asked to do quite a bit moving forward. So let's go back to our example up here. We want to recreate this with our, well, except not all marked up, right? So this is just my markings. We want to recreate this using our calculator from the original data. Good. So it'll look just like this. So let's go back to our original data, way up here. And we were given these results, right? So given these results, let's just use our calculator to create that box plot. So let's go over to our calculator. Okay, so we're going to start by inputting the data. So let's go stat, edit, and we should already have all our information in there from before. If not, well, then you would just, of course, type it in. Let's scoot this over here a little bit. So here it is, list 2. We have 6.5, 12, 14.4, 14.4, 13, all the way down. Okay, so list 2 has all my points. I want to create a box plot of list 2. So this is what you're going to do. First, step 1, we have to hit this button up here that says y equals. Okay, so select that. Now this is a place where we input equations. And at this point, we don't want anything on here. So we want one of two things to happen. Either we use these arrows to go over to where the equal sign is highlighted. See, the equal sign is blinking. and then we hit enter one time, and then we can use the arrows to move away. What that means is that this equation has been deactivated. See how the equal sign is no longer dark? It was dark before, and now it's no longer dark. That means it's not highlighted, so it won't affect us, right? We don't want it to affect us. Let's do that again. Let's go over here. If you use the arrows to select the equal sign and hit enter, and then move away, you see now the equal sign is dark. That means it's active. Okay, we don't want any active equations on here. So highlight any equations on there. You can use your arrows, go down the list and deactivate them. Or if you don't need them at all, why have them there at all? You could just erase them. So you can just hit clear and it'll erase the equation and you don't have to worry about it. That feature of highlighting the equal sign is useful when we type in an equation we might need down the road, but for now it's just getting in our way, so we can deactivate it and not erase it. Okay, but if you don't need it, then you can just hit clear, erase it, make sure there's nothing there. Also, a tricky little thing, if you go all the way down, you scroll all the way down, there's some other results down there. And sometimes there's like an equation down there, right? Like, for example, there could be something like that way down there, and then people scroll up and then it disappears. So that's been a problem in the past. So go all the way down there, make sure that there's no equations down there, hit clear, everything's clear. Okay, so now that that's clear, we're going to go, next step, we're going to go to stat plot, which is right above the y equals. So we have to hit second first, then stat plot, and then we get to this menu here. We want to, so this offers some options, 1, 2, 3, 4. Okay, so we want to enter into the first option, enter first option, and then we want to use our arrows to select whether on or off. So see how the off is dark? Well, if I hit enter, then the on will be dark, right? Pretty easy. Now, maybe when you selected plot 1, maybe it was already on. That's fine, then leave it on. Okay, so then you go down by 1. Right, so you start there and you go down by 1. And now this gives you a variety of options, and we, at this moment, are going to use this one. You can see it's like a little graph of a box plot, and then it's got the little dots. On the other hand, this box plot over here doesn't have the little dots, right? So this one identifies outliers while this one doesn't. So this one doesn't do the upper and lower fence, it just extends the whisker all the way down to the minimum value, and the upper whisker extends it all the way up to the maximum value. So we don't want that one. We want this one because the point of this really is going to be to find outliers. Okay, so go there, select enter, and notice that as soon as you do that, these things down here are going to change just a little bit. Right, so it changed a little bit. Okay, so next we're going to go down here. This X list is where is the list of values for which you want to do a box plot. And note that we had them on list 2. So hit second, L2. This frequency, you want to leave it alone, leave it as a 1. And then next, how do you want to mark your outliers? A little box is fine. And then if you have one of the colored ones, it'll ask you for a color. Otherwise, I think that there's nothing there after that. Okay, so that looks pretty good. Next, once you've finished inputting those two things in there, I want to go back to stat plot for a second. So hit second, stat plot, and that again brings you to this original menu, right? So this is a menu where you get to see an overview of what we just did. We did a plot, plot 1 is on. You can see right here that it's got the little box plot with the little outliers selected. The values are going to be on list 2, and list 2, I forgot what the 1 was. Oh, frequency 1, good. So we need that to be a 1 for our situation. And then the outliers will be a little box, right? Okay, from this screen, we could see what's going on with the other plots. It's important to do that because if one of the other plots was on, then we might run into problems. We need to make sure that this one is on and that we've selected the things we want, but also we need to make sure that the other two are off. right? So these two are already off, so that's good. But when you first turn on your calculator, it might be the case that this one is on, for example, like that. And now let me go back to second stat plot, and you can see how plot 1, what I wanted, is on, but also plot 3 is on, and so we're going to have potentially an issue, especially since plot 3 has something to do with L1 and L2, and then if there's something wrong with that, you'll get an error message, and you might run into problems. So my point is, make sure that the plots we're not using are off. Plot 2 is off, right? So I'm not using it, that's good. Plot 3, let's hit enter there. Come over here, hit enter, and there. Now it's off. So we can go back to stat plot, and I can see it's off. It's off. This one's on. It's a box plot with the little outliers. List 2, frequency is 1, and the little boxes represent the outliers. So that looks good. Okay, once I have all those values in there, I'm going to hit this button that says zoom, and I want to scroll down, and I want to use zoom stat. That's what I want. Zoom stat, hit enter, and there's our box plot, right? So here's our little box. Right? Remember, it had a tiny little nub. So this is the calculator's version of this guy. Right? So this is what the, oops. So this is the calculator's version of that. Notice that the calculator doesn't include the fences. So that's something that's not on there. Also notice, okay, so we put the little outlier as a little box. If we had used a star, we can go back to that. Some people like that better. So let's go to stat plot, enter, and then we can come back down here, and then maybe, oh, there's no stars, but there's a little plus sign. Hit enter to select the little plus sign. And now if we go to zoom, and then you can use your arrows to go down, or you can just hit the number 9. It'll select zoom stat. And now it's a little plus sign instead of a little box. Okay, so there's our outlier. Well, as you can see, we don't actually have any numerical sort of values. We can just kind of see the shape of it. But if you wanted to know what is that value there, we can hit this button that says trace, and then that little blinking X there tells you that that's the median at 13.6, and then we can use our arrows, and it jumps over to Q1. Q1 is a 12, and then it jumps down to this value. Remember, this is the smallest value that's to the right of the lower fence. So it's the smallest value that's not considered to be an outlier on the lower side. And then we can go one more time, and then it jumps over to the one that really is that lower, that minimum value, that outlier. Good. We can also go in the other direction, and we had the median, then we have Q3, and then we had that max value. Good. Max of 14.5. So that's how we can recreate a box plot using our technology. And moving forward, starting in like chapter 6, what we're going to use this for is to make sure or identify if there are any outliers, and also to just kind of get a sense of the distribution of our data. Right? As I pointed out before, this lets me know that about 25% of my values in my data set are clumped up in this top little part, right? Because the distance between Q3 and Q4 is so tiny, it lets me know that they're clumped up around there, right? So this is going to have a left skewed left. This data is skewed left, right? There's a left tail coming way out here. Okay, this is a good place to stop.